Welcome to the Decoding HVAC Podcast, powered by Fujitsu Airstage, bringing you smart solutions, industry trends, and pro tips to keep you in the know. Well, Matt, here we are with another episode. You just moved into a new house and you were telling us you ran into some humidification or condensation issues. What's going on there?
Not necessarily issues, but just a design, right? So when we talk about on today's episode, as it pertains to ductless, we were running air conditioning, right? We're pulling humidity out of the air. So the house my wife and I bought, and we noticed when we were walking around the house, the one side of the house was the ground was more soupy. We'll leave it at that. The systems that are in the house, conventional split heat pump, one in the attic, one in the crawl space. And what I don't know why, the builder, I guess when they built the house, and we're not the first owner, we're the second owners. They put both condensate lines from both systems, terminating the crawl space between the two HVAC units. So all the moisture that is being pulled out of the house is being drained on one side. We're talking about the time this episode is recorded. It's about July or August. So it is super hot. It was super humid. We were having record degree humidity and heat indexes. So those bad boys were pumping 100% night and day pouring water. So we were able to kind of get that remediated. But at the end of the day, as I'm thinking about, hey, there could have been different thoughts or processes of when they laid this system out of where we could have put the drains to get the condensation out of the house.
So walk me through that. What does it look like today? Is it just gravity fed? Are they pumping it out? What's it look like now?
One system is in the attic, so it's all gravity fed. The one in the crawl space, it's feeding into a condensate pump and then pumping it up. The issue is it's really not pumping it very high to get it out of the crawl space. A simple, you got to think. So with all that water going somewhere, because once it's created, you can't make it go away. You have to deal with it. It could have simply been, Darin, that they cut a hole in the other side of the house and have one system drain on one side and on the other. I get it for aesthetics or whatever, but I much rather make sure that I know that I can keep an eye on the condensation that's coming out and not having issues with all that moisture sitting on one side. And luckily it was far enough from the house, but still could be an issue.
Okay, so for those of us that maybe don't know how to manage this, how are you going to manage it going forward?
Very simple. What we're going to do is we're actually going to get the crawl space encapsulated. So that's from an air filtration and quality standpoint. And what we're going to do is we're going to take that condensate pump that the crawl space unit is being dumped into. I'm going to move that and put it out the other side of my crawl space. And I'm adding a dehumidifier. I'm going to try to pull even more moisture out of the crawl space, and I'm going to dump it outside a different location. I want to make sure that I'm looking at all what will be eventually 3 condensation drain lines so that I can watch the water and the condensation coming out. If I see one that's not having anything coming out of it at all, guess what? Remember, once water's created, you got to deal with it. That means it's sitting in a unit or it's sitting in a pan. That's bad news.
Is the system sloped properly?
Yeah, everything is sloped properly, but I think also the conditions that the forecast was having, those 3 weeks, it was just causing so much moisture. And also for us that, live in a crawl space environment where the homes are built, proper ventilation in crawl spaces, some people understand it and some don't, right? So some people will think, oh, I'm going to open up my crawl space vents and let all that air flow through. It's going to move the air, have air exchanges. Well, that's probably not the best thing to do in a humid coastal market.
You mentioned water backing up. What about float switches to shut the system down?
Yeah, if a system has a pan underneath the unit, there's a condensation safety overflow so that when water starts hitting a pan, it's supposed to kill the fan in the unit, shut it down. And that's your notice of saying, hey, something's not right with my air conditioning. Let's go take a look at it. Why isn't it running? And then, keeps the system from keep running and pumping out, water.
Gotcha.
I also think we're talking about a house I bought. We're talking about, conventional systems. But for the listeners, for ductless applications, that's one thing we have to be very cognizant of from a design and application is, when we're putting in a ductless system that may have multiple indoor units where we may be walking a house and we say that's the perfect spot for one of our wall mount units. It may be the perfect spot. It may be where the wife or the homeowner says that's where she wants to have that air handler. That's it. That's great. But how are we going to get the water from an inside room and getting the condensation lines out? We always have to be thinking of how am I going to connect the indoor unit to my outdoor unit from a copper line set perspective so that we have a system, a circuit, refrigerant circuit. But then just as much as important is how am I going to get that water out? So I can have multiple penetrations through my house and have lines, the drain lines poking out. Some people don't prefer that. Some may be able to have that common drain into a larger drain to accommodate for the flow. And whether you're on city or septic, will dictate what you can do with that condensate. And Darin, you're right. I mean, there's all kinds of different things that we can look at, floats and switches and humidity sensors, just like on the water side, where if there's a water spill from a water heater, that it shuts down and notifies. But just one thing, it's easy to say, hey, I'm going to put in a multi-zone system, but we have to make sure that we're understanding where that system goes and address the condensation.
So what about oversizing a system, right? We want to put the biggest one in, but that's not always the best because they can cool quickly, but they really don't run long enough to dehumidify, right?
Yeah, absolutely. Load calculations are key. It's an exact science, right? If I'm not running long enough, I'm not removing humidity. If I run too short, I'm short cycling, and then the furniture is swelling, the doors kind of stick on the jambs. You're not removing the humidity. And again, what we feel on our skin, what we call latent, that's what we feel on our skin, that humidity. That's the real feel. I'm doing some air quotes, temperature we feel. So if I'm lowering humidity, I can actually have a higher temperature, but I feel more comfortable. But when we have a lot of moisture in the air, that thermostat's going to have to be turned down to get that water out of there.
And what about basic maintenance, right? We got a drain line we need to clear. There's filters, coils to clean. How important is that when we're talking about condensation?
Super. You'd be surprised what funk is in the air. Everybody loves the air fryer. Oh man, throw some hot wings in there, but you think about all these, from cooking to household chemicals, there's funk that gets in the air. So when that air circulates and crosses the coil and condenses and it gets in that condensate and it drains into the pan and then out the drain lines, those drain lines, just like cholesterol in our systems, it can get gunked up. And if we don't clear them out, oh my gosh, you have a catastrophic failure, kind of like the analogy of a heart attack. I'm having a catastrophic failure because my veins and my condensate line is blocked up. I can't get the water out. So yeah, maintenance is big. Making sure that you're clearing out those lines and making sure that you've got a free flow. And sags, right? You'd be surprised. Sometimes people throw in the condensate lines, just to throw them in there, think, oh, I'm good. But if you don't have the right fall, the water, can trap into the PVC. If it sags down, it's hard to get it back up. So tons of different things to consider.
Well, Matt, thanks for sharing that story. And if you got any questions out there that you'd like us to address or topics, please reach out to us via email at decodinghvacpodcast@gmail.com. Thank you.